Hello everyone. Welcome back to my channel. Let us now study something about big data in context of data science. 204 million email sends, 300,000 login to Facebook, 1.3 million videos on YouTube, 2 millions of Google search, 100,000 tweets, 20 hours of videos and 62,000 hours of music download. We didn't realize when our data became big data. With the increased use of technology, the size of data is increasing exponentially in business and society. Big data is the next wave of performance improvement and business transformation. It can bring you a new level of insight and opportunity, more efficient, fact based decision making, a new source of business value, and a competitive advantage. So, the biggest question that comes into our mind is how do you classify any data as big data? Well, it is only possible with the concept of 5 V's. The first V is volume. Organizations collect data from a variety of sources, including business transactions, social media, and information from sensors or machine to machine data. In the past, storing it would have been a problem, but new technologies such as Hadoop have eased the burden. Data streams are being generated at high speed, and they must be dealt with in a timely manner. RFID tags, sensors, and smart metering are driving the need to deal with torrents of data in real time. The third V stands for variety. Data comes in all types of format: structured, numerical data in traditional databases, to unstructured text documents, email, video, audio, stock data, and financial transactions. The fourth V is of veracity. Accuracy and trustworthiness of generated data is termed as veracity. The fifth and the last V stands for value. It represents both money and experience. It provides faster connections with customers, better user experience, reduced time lag between transactions, and many more things. Some of the approaches used on traditional data can also be implemented on big data. Collecting and pre-processing big data is essential to help organize the data before doing analysis or making predictions, as is grouping the data into classes or categories. While working with big data, things can be a little more complex. Beyond the simple distinction of numerical and categorical data, example of big data can be text data, image data, video data, audio data, and many more. To exemplify this, let us look at some of the examples of big data. As one of the largest online communities, Facebook keeps track of its username, personal data, photos, videos, and recorded messages, and so on. This means that their data has a lot of variety. And with over 2 billion users worldwide, the volume of data stored on their servers is tremendous. Facebook requires real time recording of aggregate voice of the users, and it applies many analytical tools for its mobile application. This means that the company is investing in boosting its real time data processing power, increasing the velocity of its data set, and many more. Now, where else can we find big data? Think of a vehicle that reads its environment and reacts accordingly, much like a human driver, but also analyzing other sources of information that will make the trip safer, faster, and more efficient. But with it, it generates a lot of data. Analyzing vast amount of medical data from different locations and demographics will allow to determine which conditions will improve the effectiveness of certain treatments. Big data analysis will reveal patterns and connections that will vastly improve the most of the human activities. But now you might be wondering how to store and process this big data. To do this job, we have various frameworks like Cassandra, Hadoop, and Apache Spark. Storing structured data was not that difficult, but as time passed by, internet took over the world and generated enormous amount of semi-structured and structured data in form of text, videos, and music, as seen in our previous examples as well. But how do we store and process such data? Multiple storage units and processors were undoubtedly the need of the hour. This was incorporated in the concept of Hadoop that could store and process vast amount of any data efficiently using a cluster of commodity hardware. Hadoop consisted of three components that were specifically designed to work on big data applications. In order to capitalize on data, the first step is storing it. Therefore, the first component of Hadoop is its storage unit, that is the Hadoop Distributed File System or HDFS. Storing massive amount of data on one computer is not feasible. Hence, data is distributed among various computers and stored in blocks. If we have 600 MB of data to be stored, HDFS splits the data into multiple blocks of data that are then stored in several nodes in the cluster. 128 MB is the default size of each block, so it will take 4 blocks to store 512 MBs, and the remaining 88 MB will be stored in any other block. So now you might be wondering, what if one data node crashes? Do we lose that specific block? Well, no. HDFS make copies of data and store it across multiple systems. When data block is created, a replica of it is also created in a number of 3. And this is known as the replication method. Because of this, the data is not lost at any cost, even if one data node crashes. This makes HDFS fault tolerant in nature. After storing data successfully, it needs to be processed. This is where the second component of Hadoop, MapReduce, comes into play. In traditional data processing method, entire data would be processed on a single machine having a single processor. This consumed time and was insufficient, especially processing large volume of data. To overcome this, MapReduce splits data into parts and processes them separately on different data nodes. The individual result is then aggregated to give the final output. Now that we have our MapReduce job ready, it is time for us to run it on our Hadoop cluster. This is done with the help of some set of resources like RAM, network bandwidth, or CPU. Multiple jobs runs on Hadoop simultaneously, and each of them needs some resources to complete the task successfully. To efficiently manage these resources, we have the third component of Hadoop, which is known as Yarn. Yarn consists of a resource manager, node manager, application master, and some containers. Resource manager assigns resources. The node manager handles the node and manages the resource usage in the node. The container holds a collection of physical resources. Suppose we want to process the MapReduce job that we had created. First, the application master requests the container from the node manager. Once the node manager gets the resources, it sends them to the resource manager. This way, Yarn processes job request and manages cluster resources in Hadoop. In addition to these components, Hadoop also have various big data tools and frameworks dedicated to managing, processing, and analyzing data. The Hadoop ecosystem comprises of several other components like Hive, Pig, Apache Spark, Flume, and Scoop. The Hadoop ecosystem works together on big data management. So that was all for this video, and I hope that the concept of big data and the working of Hadoop will be clear to you. And if you like the content, then don't forget to like, share, and subscribe this channel. Thank you.